Alright, hello everybody. Welcome to Pre-Cal Trig. This is the Unit 3 test, Part 2. We're going to go over the types of questions that you'll see on the Part 2 so that you can complete yours. They are very much similar. So for question 1, we're starting with the graph of the ellipse. So we have x plus 1 squared, I forgot to put the squared, I'm sorry, over 9 plus y minus 1/2 squared over 16 equals 1. So we'll start by pulling out the center. Because this is in standard form, it's easy to find x minus h. So with the x we have x plus 1. So we've got to subtract a negative 1 in order to turn that into x plus 1. So the center of our circle, the x-coordinate is negative 1. Kind of think of it as the opposite of what you see. Then we're going to move over to the y minus 1/2. That's going to be our h-coordinate. I'm sorry, our k-coordinate over there with the y. And that's just going to be positive 1/2 because we're subtracting 1/2. So again, look at it kind of as the opposite of what you see. H is negative 1 and k is positive 1/2. Now we're going to find the major axis endpoints, the minor axis endpoints, and the foci all originating from that center. But first we've got to determine what the major axis is doing. Is it traveling in the direction of the y-axis or in the direction of the x-axis? Well, we look at the denominators, 9 and 16. So let's go ahead and plot that point, and I'll just call it C on my graph. A lot of students plotted points, but they didn't label anything. So make sure that you label the points that you're putting on that graph, or you won't get full credit. Okay, so now we're going to look at the 9 and the 16. And then 16 is bigger than 9, so our major axis is going in the direction of the x-axis. It's going up and down. So we're going to have to calculate b, so we'll know what to add and subtract to the y-coordinate, which is 1/2. So b squared is equal to 16. Take the square root of both sides, and b is equal to plus or minus 4. Now, this is not a length and measurement, this is a direction, so we can have a positive and negative direction. Alright, so go back to your center and only look at the y-coordinate, which is 1/2. So we're going to add 1/2. Let me write those down. Negative 1 and positive 1/2. Look at the y. The y is 1/2. I'm kind of modeling how to show your work. So add 4 to 1/2. We're not going to do anything with the x, so go ahead and put negative 1 up there. And then 4 plus 1/2 is 4 and 1/2. Now there's another endpoint. There are two endpoints on each axis. The axis, or the axes, are lines. Okay, so now we're going to subtract 4 from 1/2. We're going to leave that y-coordinate alone. But let me go ahead and plot that point on my graph before I forget. So go over negative 1, go up positive 4 and 1/2. And then you can label those. I'll label it major because we have a major and a minor. That's one endpoint. Find the other endpoint by subtracting 4 this time. So negative 4 plus a positive 1/2, you would subtract and you'd get 3 and 1/2, or 3.5. You have more negatives than positives, so it's going to be negative 3.5. So your other endpoint is negative 1, negative 3.5. Alright, so for the minor axis, we'll go to the 9 and take the square root of 9, and that's going to be plus or minus 3. And we're going to add 3 and subtract 3 from the x-coordinate of the center. So positive 3 plus a negative 1 is a positive 2. And we'll leave that 1/2 alone. We're not moving in that direction, so it's still going to be 1/2. Take negative 1 plus a negative 3, and you'll get a negative 4 when you add those together, and leave the 1/2 alone. Go ahead and plot those points. And I forgot to add that second coordinate underneath the major axis endpoints. We'll go back and do that in a minute. But we're essentially starting in the center, moving to the right 3 units and to the left 3 units. And then we'll label those. And then we'll kind of sketch those together with a smooth curve. It's not going to be diamond shaped, it's going to be elliptical shaped. Don't forget to label the points. I'll call that minor 1 and minor 2. Alright, now we need to calculate the foci, where the distance between the center, and we're going to go in the direction of the major axis. That's where the foci lie. So we're going to be going in the y direction, starting at the center. So we have a squared. Am I going to use this formula, a squared plus b squared equals c squared? If you connect to Quizlet, those formulas will be there for you to readily look up. And if I add a squared, which is 9, plus b squared, which is 16, I get 25. And I take the square root of 25, I get 5. That doesn't look right. Let me look up my formulas real quick. Alright, it's c squared equal b squared minus a squared. So we'll take that larger number, 16, and subtract that smaller denominator, 9. That's c squared minus a squared is 7. We need to take the square root of both sides. To get the square root of c squared is c, and the square root of 7 is plus or minus square root of 7. Now I'm going to write this without taking that square root of 7 out from underneath the radical, because every time you do, it's not a perfect square. You'll get an approximation. You'll introduce error in. So I'm just going to, again, remember it's going in the direction of the y-axis, so we're going to be adding and subtracting the square root of 7 to the y-coordinate of the center of your circle. And that y-coordinate is 1/2. So it's going to be 1/2 plus or minus the square root of 7, and that x-coordinate is going to be -1. We don't do anything with that y-coordinate because we're not moving in that direction. Alright, now let's get everything filled in, and then we'll move on to question number 2. Alright, quite a bit of work to show, but make sure that you show everything that you can, especially by sketching. Every one of these problems requires some kind of a sketch as a reference. It's very, very important in question number 1 that you don't just put the answers, but that you plot the points and then you label them on the graph. Alright, now to plot the foci, if you notice, I went ahead and took the square root of 7 and I'm going to use that as an approximation. I'm going to round it to the nearest hundredth. And so I'm going to be adding and subtracting 2.65 to 1/2. Move up and down and get an approximate place. That doesn't have to be perfect because we are taking the square root of 7. But get those 2 points graphed or plotted on the graph for this problem. Now we did this in class. We're going to go on to question number 2. LORAN is a long-range hyperbolic navigation system, and suppose that 2 LORAN transmitters are located at the coordinates of -60, 0 and 60, 0, where the distance on the coordinate plane is measured in miles. A receiver, I'm going to go ahead and plot those 2 points, and I can see I made that sketch to the right as a reference. It's a hyperbolic sketch, and I just have it opening up left and right, because when I plot the points -60, 0 and 60, 0, it gives me a reference as to how it's opening. So I'm going to start with the X first because we're opening up in that direction. So it's going to be X minus H, that should be H, I'm sorry, not 1, X minus H squared minus Y minus K, where H and K are the center of our circle, squared over B squared equals 1. This is the equation of a hyperbola in standard form. Alright, so now if I graph this, if I make a sketch and I put the center at 0, 0, as I should, and put those 2 points -60, 0 and 60, 0, gives me a better visualization of what I'm doing. It doesn't have to be an elaborate diagram. Just going to kind of put those out there, 60, 0 and -60, 0, because I don't know whether those are the foci or the vertices yet. I need a little more information, but I want to go slow and sure. Alright, now that I've got that, I know how it's opening up, left to right, or left and right. That distance between the center to the right is 60 miles, because we're measuring in miles, and to the left is another 60 miles. Now we have a receiver located somewhere in the first quadrant. So we have a radio receiver, some kind of radio waves, or I don't know what kind of waves, measuring the distance between 2 other points, and the distance between those 2 points is 100. So if we divide 100, we get 50 to the right of the center and 50 to the left of the center. And the problem talks about difference in those distances. Again, it's an indication that this is a hyperbola because we're subtracting that difference. I'm going to go ahead and put those points on my graph, and that should be +50, 0 and -50, 0. Take a minute to let that sink in. Now when I put those points there, and I go ahead and sketch out my, just a rough sketch of what this looks like. Remember, it's a hyperbola. We're going to go through the vertices. There's one vertex and there's another, and the other 2 points at 60, 0 and -60, 0 are foci. Alright, so the distance from the center to 50, 0 is 50 miles, or 50 units. So that's going to be our A. So A squared is 2,500. And we're at the center, so we can drop that H, because H is 0. And we can fill in that part of our equation. So we have x squared sorry, this mouse drawing is slow for me. So I have x squared over, again, 50 times 50, that's a. A squared is 2,500. And now if we find b, we just put minus. Y minus 0 is just y squared over b squared. Now, one of the common mistakes is that students will take that 60 and just say, I have a measurement, 60 times 60 is 3,600. But we need to take a second look, because I said those were the foci, and the distance between the center and the foci is c. So we have a squared and c squared. We need the formula to calculate what b squared is. So I'll go back to my notes in Quizlet again. Go to our announcement page, sign up for Quizlet, and you'll have access to those formulas that we use in class for each unit. I haven't finished building Unit 4, but all of your formulas are in there for Unit 3. Okay, so the formula is a squared plus b squared equals c squared. Okay, so fill in 2,500 for a squared plus b squared equals, now c is 60, so 60 times 60 is 3,600. So we're essentially going to be subtracting 2,500 from both sides, and we'll end up with b squared equals 3,600 minus 2,500 is 1,100. And we're not going to take the square root because we need to put b squared in the denominator, so we'll just substitute that in for the denominator and then put equal to 1, and we have our equation. All right, so that's it for number 2. Let's go on to question number 3. I had a second page just in case I needed more room to work. All right, question number 3, we have an elliptically shaped garden. It's surrounded by a wood walkway. So remember, the hyperbola and the ellipse have the same equation, except for an ellipse we're adding. So the order is not going to be important other than determining what our major axis is. So depending on how you sketch this will depend on what your answer is. So other students could have a different answer, and both could be right. So the way that I sketch it is it's going, the longer axis, the major axis, is in the direction of the x-axis. So I start with x minus h squared over a squared plus y minus k squared over b squared equal 1. And it doesn't really matter the order because addition is commutative. Alright, so now that's just the garden. So I need to add some more information to my sketch. Let me take a minute and analyze that. And mine's opening up the major axis in the direction of the x-axis. So all the way across is 15. That's just the garden. So we take half of that. Half of 15 is 7.5. And then my minor axis is going to go in the direction of the y-axis. And you could draw it differently. It doesn't matter. But half of 8 is 4. So we have our A and our B. But if we get in a rush, we might think that we're finished. So let's hold on there. The center is going to be at 0, so I can take x minus 0 is x squared over. Again, half of 15 is going to be our A, that's 7.5. But we've got to remember to add the 3-meter wide walkway to the right and to the left. So let's add 3 to 7.5, and we'll get A equals not 7.5, but 10.5, because we've got to add that walkway all the way around. All right, and for the B, we're going to do the same thing. We've got 4 plus another 3 is 7. It's 8 meters all the way across. Half of that distance is 4. 4 plus another 3 is 7. So B is equal to 7. Almost sneezed. All right, so let's go ahead and finish our equation. X squared over a squared, that would be 10.5 times 10.5. And a lot of students just left it this way, but I couldn't give you full credit because it's not logical. In our mind, we would need that measurement expanded. So I want you to go ahead and multiply 10.5 times 10.5. And let me see what we get. It's 110.25. I didn't get that written down correctly. Try to remember to go back and fix that. Plus y squared over 7 times 7, and 7 times 7 is 49, equals 1. And that would be the equation of the ellipse. Just remember to put 110.25. And you have similar problems. Finish this up, ask questions if you need to, but go ahead and get this first part done. The unit tests weigh heavier than anything else and will make the biggest difference in your grade, the fastest. And you'll get to do this over and over again. Our last live CC is on Monday, and we'll draw for gift cards. You must be present to win. Everything that you're turning in on time, it doesn't have to be 100 or a perfect grade. You get an opportunity in the drawing. So you want to make sure that you attend on Monday and get your work done. All right, good luck. Let me know if you need any help.